Now let's see how the visitor pattern can be executed at the runtime. I would like to just go over very quickly. So the main thing about executing the visitor pattern at the runtime is something about double dispatch. Okay, so double dispatch means there are two patches you have to understand. Okay, let's say if I have some expression over here, let's say a plus b or 3 plus 4, whatever expression it is. The expression can be either a constant or can be an addition, which has left or right. Now, when I say any expression e, for example, e dot accept some visitor over here, and the visitor can be either an evaluator, can be pretty printer, or type checker. Okay, the first dispatch, what does it mean? When I say e dot accept, now which accept feature am I going to call? Right, that's the first patch. Every patch means depending on the dynamic depending on the dynamic type of the call targets. When I first say e.accept, e is the call targets or the context objects. Depending on what the e's dynamic type is, I'm going to call either the version of accept over constant class or over the addition class. So that's the first patch. Okay. For example, let's say if the current expression I'm trying to evaluate is an addition. So when I say e.accept, so now because e's dynamic type is actually addition, so I will go to this accept over here. And then inside, remember the implementation for accept is going to say v dot visit addition over here, right? And then we'll pass current. Now, when we say v dot visit addition, which visit addition are we going to call? Because you can see we got visit addition over here, we got visit addition over here, we got visit addition over here. So we got three possible versions. So now, let's say we are trying to evaluate, which means V's dynamic type is actually an evaluator. So now, when we say v.visit addition over here, in that case, it's going to call the visit addition feature over here for the evaluator, right? So now we got two patches, okay? So again, double dispatch simply means the first dispatch, depending on what the dynamic type is for the expression, we're going to call the corresponding version for the accept, for example, addition over here. And then, depending on what the dynamic type is for the visitor, for example, it does evaluator, then we're going to call the corresponding visit feature, in this case, visit addition, in the corresponding class that the corresponding class of the dynamic type of the visitor V. In this case, it's evaluator. So that's why we'll call the visit addition and then under evaluator. Okay, let's see how this is going to be executed at runtime, so you will see better. But you should always remember this architecture diagram for the visitor. Okay, two dispatches. Okay, now let's go to iFlow Studio and let's see that. Remember from the previous tutorial, we got test operations over here. Okay, so now we're gonna see how we evaluate E1, A2, and A1. Okay, so let's just see what's gonna happen. Okay, I'm going to also put a breakpoint over here. I already assumed that you know what this really means, right? So that's from the composite pattern tutorial. You should really review them if you got any questions. Okay, so now let's put a breakpoint. Okay, so now I can simply go to the flat view over here and then test expression operation. Okay, I'm going to put a breakpoint over here. Okay, right before I execute E1.accept. Okay, now I'm gonna run. So I believe this is the breakpoint from the previous test structure. Okay, I can remove it. Okay, and keep going. Run. Okay, so now this is what I want to see over here. When I say E1.accept eval. Okay, now let's go very slowly. This is the simple case, but still it's worth our attention. When I say E1.accept, now first dispatch, depending on what the dynamic type is for E1. Okay, in this case, remember we actually got E1 over here, the dynamic type is constant. Okay, so now that means the version of the accept that's going to be called is going to be the one that corresponds to the E1's dynamic type, which is constant. How do you see this from the debugger? Okay, now if you go to the objects panel over here, if you look at E1, you can see E1 over here, you can see under the type. So type here means constant. That means it's a constant dynamic type. So now, let's predict what's going to happen. First dispatch, depending on what the E1's dynamic type is, we're going to execute the version of accept of its dynamic type. in this case should be constant. Okay, so now that means if we say step into, we're going to go into the accept feature for constant. So now indeed, you can see now we are in the accept feature under the class constant. Okay, that's the first dispatch done. Now what about second dispatch? Because now we are under the context of constant, that's why we are calling visit constant. That's the result from the first dispatch. Now what about second dispatch? You can see v over here is of type visitor. Okay, that means the dynamic type can be either evaluator, type checker, or pretty printer, right? As we can see from the diagram over here, it can be either of the three descending classes. Now, when we say step into, we have to choose which version of the visit constant it is going to execute. Is it the evaluator, or pretty printer, or the third one, which can be also type checker. Okay, either of the three. So now let's see what the dynamic type of V is. Again, you can see that. You can see V over here, the dynamic type is simply just evaluator. Okay, so now let's predict what's going to happen. So this is the second dispatch. Second dispatch, depending on what the dynamic type is for V over here, we're going to execute the corresponding version of visit constant in the dynamic type of V. In this case, evaluator. So now, if when we say step into a routine, it is going to step into the visit constant feature of evaluator. Okay, so now let's step into it. So now indeed, you can see that we're now in evaluator and visit constant. And that one will simply just set the value, because now we are talking about simple case. We just evaluated a constant. So now you can see C is the constant that we passed, right? So now you can also see the step trace over here. We started with E1.accept, and E1 is over here, E1 is a constant of value 2. So we expect the evaluation result to be 2. Okay, that's where we started with. Let's go to the next one on the stack, and then the first dispatch will give us the accept version in constant. And the second dispatch will give us the visit constant in evaluator. Okay, the two dispatches, very important. And now to evaluate this constant over here, which is simply just E1, and E1 is of type constant and then value 2. So when we go to visit constant here, you'll simply set the evaluation result to be C.value. Okay, so if you do that, you will see eval result has been changed to 2. Okay, hopefully that's clear. And now after we done this, so now you can see that the eval result is equal to 2. That will simply set the result to be true. Okay, so this one's done. Okay, let's just do one more, and I'll leave the next one as exercise for you. Okay, let's now do A2.accept eval. Let's see how A2 looks like in terms of object structure. You can see A2 over here under object panel over here. A2 over here is an addition at the top. So that should have an right, left, and right. The children has size 2. You can see the first child over there is simply a constant, right? Because remember, A2 was created using E1 and C2, two constants. Okay, E1 is actually 2, and also C2 is actually 3. Okay, 2 and 3. Okay, so now you can see the first item for, okay, again, A2 is over here. A2 is a composite as well. So that's why you got the children over here. The first child is the left, which will be the constant of value 2 over here. And the right, and the next elements, the next node on the list will be simply an item here, also constant, and of value 3. So 2 and 3. Okay. So now that's the structure, composite structure for A2. So now let's now try to go a little bit further. Okay, let's say if you say accept, and then you will simply see the evaluation result to be 5. Okay, let's just start a debugger again, and I want to look at this particular line and see how that works. And then I'll leave this one over here as an exercise for you, because A1 is slightly more complicated. You can see that over here, this is A2. A2, the left-hand side is simply just a constant, and the right-hand side is also a constant. Okay, so when we do evaluation, we have to do the left, do the right, and then add them up together. Now for the A1 over there is slightly more complicated, because the left-hand side is actually an addition, and the right-hand side is a constant. Okay, so now let's do this one here. Okay, let's stop the debugger over here and run again. Okay, so now we're here. So now A2 is an addition. Okay, first dispatch, because A2's dynamic type is addition. So we are now going to call the accept that's defined in the addition class. Okay, let's step into it. So now you can see now it's the accept under addition. First dispatch done. So now second dispatch, because we know that V over here is of type evaluator over here, because V's dynamic type is evaluator, so we're going to call the visit addition that's defined in evaluator. That's second dispatch. Okay, let's step into it. Now you will see this is what we have, right? So now you can see 8. Remember for A over here, that's the addition we are talking about. That addition there has two children, and then the first one and the second one are both constant. Okay, so item over here, first child, is a constant of value 2. And you can see the constant over here. Okay, the first one is a constant of value 2. And the second child, the next child, is also a constant of value 3. Okay, so now let's see how we can do it. Okay, let's execute line by line, this line, this line. So now over here, that's kind of recursive call, right? Because now we say that in order to figure out the value for A, we want to evaluate its left-hand side and then the right-hand side first before we add up the result. Okay, so now let's do this very carefully, and I'll leave the A1 evaluation to you as an exercise. So now you can see that A over here, the left should be, okay, let me just do some expression call over here for you, so you will see. Okay, let me just do it here. Let me just delete all those from previous tutorial videos first. Let me delete them. Okay, now when I say A dot left, you can see A dot left is actually a constant, right? Because we got 2 plus 3. And A dot left should be a value 2. Okay, so A dot left dot accept. So again, we got another call of the visitor pattern, right? So this is, again, first dispatch. Okay, first dispatch because we know that A dot left is of dynamic type constant over here, as you can see, constant over here. So that means it is going to call the accept of the constant class. That's the first dispatch. And then let's step into it. And then you can see evaluate left is just another evaluator. So that will be the dynamic type for the second dispatch. Okay, let's do first dispatch first. So now over here, let's step into it. You can now see that, I'll step into, we are now, okay, just evaluating the left. And now let's step into it again and see how this first dispatch works. If you step into it, you will see that now we are in the accept feature of constant, right? You can see again, that's what we have. When we have A dot left and the accept, because A dot left, the dynamic type is constant. So that's why we're going to call the accept in constant. Okay, and then what's current here? Current over here is whatever the call target is, which is A dot left over here. Okay, and also what about the visitor over here? That's eval left, which is of dynamic type evaluator. Okay, second dispatch, because V over here is evaluator over here, so you know that this is going to execute the visit constant in the evaluator. Okay, so now let's step into it. You will see now we are in the visit constant in evaluator. Okay, and they're going to do the same evaluation over here. And after this, you will see, okay, back here, now we're back to the test. Now we'll do A dot right dot accept. What you should notice is now A dot left have been evaluated and the result has been stored in the eval left. Okay, let's just try that. Eval left dot eval result. Over here, it simply got 2. That makes sense because A dot left is simply of constant value 2. Okay, and then we also do A dot right dot accept. So you will do the same walkthrough. If I step over again, so you will see eval right dot eval result. That'll give you 3. Okay, so that's why when you say what's the eval result for the current addition argument over here, that should be 2 plus 3. So that's why you get this result plus this result. So this result over here plus this result over here, 2 plus 3. Okay, so once you get that, you'll see that for the current objects, the evaluator for the addition over here, the current object has an eval result 5, which is 2 plus 3. Now let's go over here now. Now back to the test over here at the top level. So now the eval result is simply just 5, and that pass. Okay, hopefully now you see 2 instances of the double dispatch. So hopefully you get a better idea. And as an exercise for you, as you can see over here, we have A1.accept, but A1 is slightly more complicated than A2. For A2, which is over here, because A2, the left hand, so this is A2, okay, just a simple addition. For A2 over here, the left is simply 2. The right is simply just another constant 3. But now for A1 is this entire addition over here, but A1.left is actually slightly more complicated. It's simply just another addition. So when you say A1.left.accept, in that case, the first dispatch is actually going to say visit addition, right? Rather than visit constant, okay? Hopefully that's something you will see. Okay, it's very important for you to really try this yourself and really try to understand how the double dispatches work for the visit pattern. If you got trouble, you can talk to me. Okay, so far we have seen how the composite and also in the previous tutorial and how the visit pattern actually work at runtime. In the next video, I'll show you some design choices you have to make. Okay, stay watching.